go to continuing from the last lesson. The last lesson was all about calculating probabilities with tree diagrams. So calculating probability with tree diagrams. Are there any questions about tree diagrams before we start our first example? And I just want to give a chance for any questions based on the previous lesson. Otherwise, we'll start straight away. I know that, is there anything you would like me to clarify from the previous lesson before we get going? Okay. I'm not seeing too many questions right now. And so all I'm going to do is I'm going to set you the following question. So this is what the question says. It says, a bag contains 12 red balls and 5 blue balls. A ball is drawn at random and then replaced, and then another ball is drawn. So there's 2 draws of the ball, but you put it back. Now, because you put the ball back, we say that the first draw is independent of the second draw. They don't affect the result because you put the ball back. I want you to start by drawing a probability tree to try and represent these 2 draws. So I'll go first draw, second draw. So step 1 is to draw the probability tree. So that's first step. Do the tree. The second step is to put the probabilities on the tree. And then the third step is to find the answer to the question. And the question says, what is the probability that both balls are red? Now, I want you to tell me when you finish the first step, say step 1 done in the chat. When you finish the second step, say step 2 done, and so on. Now, for those who are new, who might feel a bit confused, I would love a question from you in the chat, or an audio question is fine too. We can unmute you. But I just want to give a chance. Try and draw a tree that represents this situation to start with. So
Mr.
the very
S?
first, yeah.
Sorry, Mr. S, there's a question from Katja in the chat asking, when do you know when to extend the tree diagram?
Okay, so the first level of the tree diagram, the first draw has 2 options. The first option is red, and then the other one is blue. Now, if you only drew it once, your tree diagram would look like that. But because there's a second draw, your tree diagram has to be extended again. And the reason I'm only drawing 2 options is because there's only 2 different colors. And so there would be red, blue, red, blue. Now, if there was a third draw, it would start to get more complicated and we'd split the tree again. Okay, so I've done step 1 for you. That's the tree. But now each of these pathways has a different probability. And step 2, the hint I'll give you is there's 17 balls in the bag because 12 plus 5 is 17. I want to know what is going to be here and what is going to be here. This is saying, what's the probability of drawing a red? What's the probability of drawing a blue? Oh. So I want to ask a question. Why is it that my the numbers that I've put in, like 12 over 17 and 5 over 17, why have they not changed from the first draw to the second draw? Why are the numbers still the same? Can anybody tell me? Maybe you can raise your hand, or why are the numbers still the same? Let's go to Emichle. Hello? Imikle, can you hear me?
Yes, sir.
Cool, go ahead.
The ball remained the same because it was replaced and it was not removed. So it was put back into the bag. So the number stays the same.
Perfect, exactly that. Because you put them back, that's why the numbers had to stay the same. All right, now I want the answer. The question says, what is the probability that both balls are red? What you need to do is find the branch of the tree that corresponds to this situation. And I think the branch is that one over there. Let me actually turn flux this. I've got this thing in the background. Let me turn that off. You can see a bit more clearly. It's that branch. So how do we get that outcome would be considered RR or red, red. How do we get that answer? What's it going to be? So in order to get the probability of that branch's outcome, I simply have to multiply along the branches, which is 12 over 17 times 12 over 17, which is going to be 144 over 289. Or in decimals, 49.8%. 49.8%. So there's almost a 50% chance that you will get a red and then another red after that, which is interesting. But the reason it's so likely that you'll get a red and another red is there's so many red balls in the bag. Basically, that's what's happening. Okay, I want to ask you another question. Give me a thumbs up if you follow. In fact, before I move on, give me a thumbs up if you felt okay with that. Thumbs down if you felt I was going a bit fast. Okay. So here's my second question of the day, and this is a modified question. So before Amukalani, I'm going to unmute you now. I want you to work out the probability that the balls will be the same color. What's the probability that both take?
Sir, can you hear me?
I can hear you, yeah?
So I wanted to ask, so for the first 12 over 17, and then the second one, I thought that it would be 5 over 17 instead of 12 over 17 because it would need to give you 1 or like to equals to 1. I thought that's how it's supposed to work.
Okay, so each of these parts will add up to 1. Every time you make a choice, so like that bit will add up to 1, this bit would add up to 1. Every time you're making a choice, and then at the very end, so I wouldn't stress too much about that 1 per se, because there's a couple of things that are adding up to 1. But basically, you're making a choice, and every time you make a choice, both options have to add up to 1 because it has to be one of those two. Does that make sense, Amukalani?
Yes, sir.
Like, it's like if you're given however many options, it has to be one of them. And so, yeah.
Oh, okay. Thank you, sir.
So the question now is, what is the probability that the two balls that you select will be the same color? It's a little bit different to the question I've asked already. So we ask ourselves, which branches of the tree will represent a favorable outcome for this question? Remember, in probability, it's always we're looking for the favorable outcome. And so this is going to be the other branch of the tree. And so what is my answer going to be? Well, for each of the branches, if you've got multiple branches, what we need to do is we need to add them. So we take the answer from the yellow one, which is still the same. So 12 over 17 times 12 over 17. But we add the possibility of the green branch. And so what you're going to see for that is it's still over 289. but this one over here is going to be 169. And in terms of decimal, it's going to now be 58.5%. So it's more likely, it's a higher probability than the earlier one. Okay. Questions or comments from the students before we move on to a second one? Yeah, royalty, you're absolutely correct. So we don't look at the 0. No. Tato, we don't. Okay. Let us try a second one. Okay, so here is the question. Here is the question. And I want you to try and do this question for me. So example 8, it says a bag contains 5 red counters and 3 yellow counters. A counter is picked at random and then replaced in the bag. Another counter is picked and replaced in the bag. Now, because they're being put back, these events are independent. The numbers aren't going to change too much. Okay. First step is to draw the tree diagram, and I want you to put the probabilities on the tree diagram. So that's step 1. And then after you have done that, just say tree diagram done. And then we'll go on to these questions. And the whole point of this tree diagram is it's helping us understand the different possibilities when we pick something out of when we're given a choice. It's quite hard to logically keep track, whereas the tree diagram does all the hard work for us. Now, how many colors are there? Okay, that's not the prettiest tree diagram I've ever drawn, but you get the basic idea. This is choice 1 and choice 2. And I've got 8 in total. And so this should be 5 out of 8, and this should be 3 out of 8. Three out of 8. Now, if they say you must list the outcomes, now they don't always do this, but if you have to list the outcomes would just be red, 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 yellow, yellow, red, yellow, yellow. So that's an add-on sometimes that they ask for the outcomes, but you can see that from the tree diagram. Okay, any questions about the tree diagram? Otherwise, we're going to move on to the questions now. So the hard work's actually done. So now it says, determine the probability that a red counter was picked first, followed by a yellow counter. What's the answer going to be to that question? So a red counter was picked first, followed by a yellow counter. So send your answers through, guys. So red counter first, for me, that looks like it's that branch. And then a yellow counter second would be that branch. So my answer would be 5 over 8 times 3 over 8, which is going to be 15 over 64. Yeah. So it's going to be 15 over 64. Let's move on to the second one. What's the probability of a yellow followed by a yellow? Pop that in your chat. So that for me feels like it's going to be this branch, which is 3/8 times 3/8, which is 9/64. Okay, well, let's jump because the third one's too easy. I want to see, can you guys figure out this last one? What's the probability that a red counter was picked and then a yellow, or a yellow counter and then a red? What's the probability going to be of that? There's a couple more words going on in that one. Because when we say the word or, what that does mean something specifically. So the key idea is that there are actually two possible pathways. If it was a red counter and then a yellow, for me, it would be this one over here. But it says or, so basically that's a favorable outcome. But another favorable outcome would be yellow and then red, which is this one here. So what I get is I know that the first red tick is 15/64 because I did that earlier in the question. Plus, I've also got to worry about the other one, which is 3/8 times 5/8, which is going to be, so I've got 15/64 plus 15/64. And so we should have 30/64 or 15/32. So the or just meant that there were two pathways that were possible. Guys, just give me a thumbs up if you're feeling okay. Thumbs down if you're feeling a little bit lost. Okay. Keep those thumbs. I need to know how my people are doing. Okay, so there's a bit of a mixture. All right. Now, we're going to do one more question before the break, and a lot of you are still sort of getting to this idea. So let's do one more question like this before I go on to other stuff. So all I want to do is, I'm not going to do this whole question. All I want you to do, we'll ignore the A because we know the two events are independent. This is an example, just like the last one where we took two out. I want you to draw a tree diagram to illustrate the situation. And I want you to fill in the probabilities along the branches of the tree diagram. And you're given a bag and it's got 3 red, 2 blue, and 5 white. So draw me a probability tree showing the different possibilities. You are selecting 2 balls, but you're replacing those balls after you select. And then I will highlight a few questions that I want you to try and work out. And then what I want is I want you to tell me when you've done the tree diagram. Just type tree in the chat so I know roughly how many of you are on board with me. Okay, so those who have finished the tree diagram, there are 3 questions that I've chosen to give you. You can try those, but for those who are feeling a bit unsure, I think you should start with a tree that looks like this, which has the 3 different options, which are red, blue, and white. But then each of these has 3 options because there are 3 colors. So red, blue, white, red, blue, white, red, blue, white. Now the key variable is this. This is going to add up to 10. And so it's going to be 3 out of 10, 2 out of 10, 5 out of 10. Okay, you probably don't have to do as much writing as I'm doing. So that's what your probability tree should look like. And you can see the different results like red, 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 blue, red, white. What is the probability of selecting 2 blue balls? So if you look at this question, what is the probability of selecting all those two blue balls? Which branch of the tree is going to show you 2 blue balls? So blue is just going to be 2 over 10 times 2 over 10, which is 4 over 100, or 1 out of 25. Yeah. Now I want to know, what about selecting a blue ball and then a white ball? Which one is that going to be? So what is the probability of a blue and then a white? Well, that's going to be 10 over 100 or 1 over 10. Okay, what I like what I'm seeing, Tato. I like what I'm seeing. Now, the final question before our break is, can you work out what is the probability of selecting 2 balls of the same color? What is that probability? And which pathways are we most interested in? So we're interested in this. There's 9 different possibilities that we outcomes you can see here, like R, 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 B, but we're only interested in red, red, blue, blue, or what would the last one be? It would be white, white. So those are the 3 options that we would consider favorable. Now, how do we get the probability for that when we have 3 different branches that are valid? So for me, that is what the answer would be. And if I look at that, it's all over 100. So that's easy enough. And then if I look at that, 3 times 3 is 9 plus 4. And so that's 38 over 100, which is either 0.38 or some of you are writing 19 over 50. Yeah. All right. My people, I know I've been going a little bit quickly, but just give me another little vote, because after the break, we are going to consider the situation where we're going to modify this question slightly. So I just want to see that I've got you all on the bus, so that if the bus takes a left turn, no one falls off the bus. Okay. So you don't understand the last part. So Tato, all we're trying to do is, because there's 3 different pathways that we could take that are correct for the question, we add the 3 different pathways in our answer. So that's all we were trying to do. Okay. All right. Before we move on to the second part, I want everybody to turn their cameras on, and I want to see you stretching. I want to see your lovely faces. I want to see your body language. And, you know, like, I think we can feel quite proud of ourselves for, working hard now. And so I'm going to stand up and stretch. And Lebo, if you could just help me recognize those students who are going the extra mile to shine brightly and encourage each other. Oh, that feels good.
Come on, guys, please join us in the stretch. Give your mind a break. You deserve it.
Oh, I feel so good.
All that hard work.
Don't let me have all the fun, guys.
Shout out to Nolwazi, Tofi, Nobesutu, William, Tato, Lesejo. Yes, guys, your body will thank you.
Yes, I can hear it whispering. Thank you, thank you.
Shout out to Nikki, loving this energy.
There we go, Tato looking good. Oh, I feel alive.
Shout out to Lesejo.
Welcome. Okay, so no maths lesson would be a thing without a brain break. So here is your brain break question. So what is the maximum number of times you can subtract 5 from the number 25? Let's get those answers coming in. Aha. I think some of you are. Okay. So this is a bit of a tricky one because of the wording, right? But if you think about how many times can you subtract the number 5 from 25, once you take away 5 from 25, you have 20. And so that is the link, or the sort of the sneaky bit about this question. The answer to this question is the following. It is 1. Because the moment you take away 5 from 25, it's 20. And so even though, yeah, basically it's the way the question is phrased. Okay, so well done. I see lots of you got that right. But if you got caught out, don't worry. I deliberately went and chose something a little bit sneaky. Okay, so let's get back to part 2 of the lesson. Angel, did I catch you? That was the intent. The brain break always kind of tries to be a bit sneaky. I'm glad I caught some of you. And yeah, I caught Lebo at the beginning of the lesson too. I always try out my brain breaks on Lebo, and thought you would enjoy this one. All right, so now what's going to happen is we're going to talk about another type of question. And this question is called drawing without replacing. And when we draw without replacing, the events are no longer independent. They're now dependent because, for example, if I have a bunch of balls in a jar and I take out one and I don't put it back, I've reduced the number of I've reduced the amount of a certain color. And so we can still use the tree diagram way of working out, but we need to start making some adjustments to our numbers. Okay, so that is the type of situation I want to think about here. So let's read through the question. It says, consider a jar containing 7 red balls and 4 blue balls. 2 balls are selected and are not replaced. This means that the first ball is not returned to the jar before the second ball is selected. Draw the tree diagram to illustrate the situation and fill in the probabilities on the branch. Okay, so what is the same? What is different? What is the same is that we're still only choosing 2 balls. So when I draw my tree, I'm pretty confident my tree is going to look still like this because there's still only 2 colors. So I'm still going to have, was it red and blue? So I'm going to put R and B and R and B, because even though I'm not replacing the ball, the colors are still the same. So give me a thumbs up if you understand how I can still draw this diagram before I go any further. I need to make sure you understand the different options, and then we can talk probability. Okay. Now, the first thing is the very first choice, the first draw, the first selection is going to be here. And because the first selection, nothing has changed, I should do this exactly as before. So what is going to be on the red branch and what is going to be on the blue branch? That's what I want to ask in the chat. So this is for the first draw, not the second draw. I want to know what is going to be on that first branch and what is going to be on the second branch in terms of probability. So we've got 7 balls and 4 blue balls. So for me, the important number is 11. I want to know what is on the red column, what is on the blue column. Yeah, so the red column will just be 7 out of 11, and the blue column will be 4 out of 11. So everything is pretty much the same up till now. However, there's a little bit of a trick coming on now. If I've taken a red ball out of the container, so let's just focus for a moment on this branch over here. If I've taken a ball out and I haven't replaced it, how many balls are left inside the container? So I've taken a ball out and I haven't replaced it. How many are left inside the container? Okay, there's 10. Yeah. Now this is an important idea because whenever I go to the second layer, what you're going to find is that this is going to be out of 10. It's no longer going to be out of 11 because you took one out and you haven't put it back. But here's the thing. If I've taken a red ball out, there were originally 7 red balls, but because I took one of the reds out, the probability of choosing a red again is not going to be, well, it's going to be 6 out of 10. So take a moment, do you understand, and give me a thumbs up if you understand why the second choice of a red is 6 out of 10. Okay, William, I see you. Okay. Now, what is the probability of drawing a blue ball on your second round? What's this one over here going to be? So if you took out one ball at the beginning and there were 11, you've now drawn a red one. For me, this should just be 4 out of 10. So you remember, you still got, you didn't take a blue ball out over here. You just took a red one. So if you took a red one out, there's still going to be the same number of blue ones, which is 4, and the number of items is 10 inside. Now let's go down. This gets easier the more we do it. So let's go down and focus on this branch now. We're going to focus on this branch. So you drew a blue one, and now I'm going to try and work out what is the probability of this branch over here. Now remember, you chose a blue one. What do we think? How many balls are there in the container over here? There's still only 10, but because you chose a blue one to start with, what is this one over here going to be? So because we know it's out of 10, because we picked up one ball, and because it was a blue ball, all 7 are left here. Now, what's this one at the bottom going to be? So this one is going to be 3 out of 10. Yeah. So the only difference when we don't replace the balls is that we have to bring the denominator down by 1. You'll notice it went from 11 to 10. And then if we chose a red, the red went down by 1. If we chose a blue, the blue went down by 1. And that's it. Now, let's use our tree diagram to answer this question. First question, what is the probability in this situation that both balls are red? I want you to try and work it out using what you've learned so far. What's the probability using your tree diagram that both balls selected are red when you're not replacing that first ball? And if you're feeling brave enough, why don't you unmute yourself and you can tell me your answer? I'd love to hear it, your lovely voice. Who's feeling like they want to share their? So which pathway is going to be red, red? It feels to me like it should be this one. Okay, William, let's go to you. What is your answer, William?
Sir, my answer is 21 over 55.
21 over 55. I think I get the same as you. I would have done 711 times 6 over 10, which is 42 over 110, which is the same as 21 over 55. William, high five. Fantastic. Now, I want to know what is the probability of the first ball being red and the second ball being blue. So I want to know what the chance of this one is. So that was for I. First ball is red, second ball is blue. It's just going to be 7 over 11 times 4 over 10, which is 14 over 55. Okay. I like what I'm seeing in the chat, Tato. I like what I'm seeing, Owami. 14 over 55 looks good to me. Now, what is the probability of at least one of the balls being red? Now think about which pathways would be favorable if at least one of them is red. See if you can work out that third one for me. Oh, Nawazi, you're getting sneaky. I see what you did there. But now, are you correct? That's the question. There's a couple of different ways to do this. The first one I want to ask you, though, is at least one of the balls is red. So I think that qualifies as an outcome. That qualifies. And that qualifies. The only one that doesn't qualify for this question is BB or blue, blue. So now, can you get the answer from that? So if you want to get the probability of all, so basically 3 of the branches, all you need to do is go 7 over 11 times 6 over 10 plus 7 over 11 times 4 over 10 plus 4 over 11 times 7 over 10. Or you could go, the other way of possibly doing it would be to go 1 minus 4 over 11 times 3 over 10. That would also give you the answer, because you're just saying 1 minus the one probability that it's not. And so your final answer should be 49 out of 55. No, that's it. Okay. Now, I know that last one would have maybe caught you a little bit, but remember, at least one of the balls is red. Is saying anything that has a red in it is a favorable answer. So Reniwe, it's just to say that if I look at all these probabilities together, let me put that back. If I look at all these final probabilities at the end here, they must add up to 1. So what I could do, instead of adding up all 3 of them, I could just work out this last one and take it away from 1. And whatever is left will be the remaining ones. But I think for most of you, it probably is easier to just go and add up each branch that you got the answer for. Okay. Let's try and squeeze in one more question for today. That's it, and the last one. So here is the question from the beginning of the lesson with one slight modification, and then we're done for today. So a bag contains 12 red balls and 5 blue balls. A ball is drawn at random and not replaced. Then another ball is drawn. What is the probability that both balls are red? This is your drop the mic moment. It is time for you to use those skills from today, draw a fantastic tree diagram, and pop that answer into the chat. I believe in you.
You can do it, guys. So that is what my tree looks like. And so now the question is, what is the probability that both balls are red? So for me, that is going to be this one over here. And so what is the answer we're going to get? It is going to be 12 over 17 times 11 over 16, which I take it you're using your calculators. So let's see what I get. at 12, 17 times by, I'm getting a decimal. Let me just pull up the answer here. So you should get 33 over 68 as per the answer. Yeah, there we go. You can see the answer there, 33 over 68. All right, people. I am super impressed by your application today. In just summing up what we did today, we looked at tree diagrams where we replaced the balls back into the container. And then we also looked at those where they weren't independent anymore, where they were affected. And we had to adjust the second branch of the tree to take into account that the ball wasn't placed back in the container. And what we learned was that actually it's just a subtle modification. Most of the methods we've learned so far work pretty well on these types of questions. Okay,